Okay, morning wormace friends. This morning and every morning what I do first thing in the morning is tend to my coffee grounds. It's quite a little bit that I'm getting. I only asked one coffee store to save me their coffee grounds, and holy cow, I never dreamt that they would go through as much. And so the problem is they come in these little, they're like a hockey puck. So I get them, and I think they might still be a little bit moist. You can see the color differences between these two coffee grinds. And you may not think any of this is important, but under my understanding is that it's extremely important. I'm using this to feed the worms. So I'm going to compost it. But the amount of nitrogen in these coffee grinds is what I'm interested in, because these are going to be used for agriculture amendments and agriculture, eco-ag, carbon farming slash microbial farming. So I want to focus on retaining that nitrogen and retaining it in a form that plants are going to use. And so that means to make sure that the nitrogen that's in these doesn't get converted to the nitrate form. How that happens is with anaerobic bacteria. So my goal is to prevent those anaerobic conditions as fast as possible after I receive these coffee grinds. So luckily right now, since it's winter, they freeze pretty quick when they get them out into the, they put them in a trash can for me. So freezes them down, which basically slows way down the microbial activity. Then I bring them home and I get them in these great big huge tubs, and I just start breaking them up with my hand because they're still fairly dry coming out of that. I don't know if that's a new industrial type of coffee processor that is more eco-minded and carbon friendly, so that when it maybe steams this coffee grind, it's so hot that when it comes out, it seems to dry. I need to just visit them and see how that coffee maker is working, because it seems to be a lot better than just if they were to get the coffee grinds and put them into a, I don't know, the old system was just like a wet cup full of coffee grinds. So this system seems to be really on par with the carbon-friendly notion of, you know, nitrogen and nitrates, and preserving these grinds for the intention of being recycled or used as a, let's call them fertilizers. Even though fertilizers kind of have a bad rap right now, that doesn't necessarily mean that all fertilizers are bad. Now, it gets technical. So when they come in, this is 1 week's amount, and if you can see, like, the level is probably a good 3 to 4 inches. And what I'm finding, I thought it would be okay, that 3 to 4 inches with this much, even just this much moisture, which these look dry, but there is moisture in there, with that very small amount of moisture, and see how finely ground up they are. So that limits the space the air can penetrate down in here. Now, I don't know how far down in this air can penetrate. I don't know what gravity can do to push that below that surface area. But since it's such a small, now the other thing I may do is figure out what else it is that I'm going to be using in the compost bins for these red wigglers. I do use a really, I get flaky sawdust or wood chips, I guess, from the Tractor Supply. And I might be able to figure out, okay, well, I'm always going to use these coffee grinds in these breeder bins, and so I'm going to use these flaky sawdust and incorporate those into the coffee grinds so that we get better air penetration to keep it more aerobic, and only the bacteria that will be utilizing this coffee grind will be the aerobics, and then therefore they will convert that nitrogen into ammonia ammonium and not ammonia. Ammonia is it's like a chicken. It's a bad, I think, form that you don't want. So you want to convert it to ammonium, NH4, which is for the plants to utilize. So that's our goal here, is to take whatever nitrogen is locked in these coffee grounds right now. I want to put the stop on any type of decomposition for right now because I don't need these coffee grinds in the worm bins just yet. My herd is not as large as I would like it to be so that I could just plug this much into them every week and get them breaking it down aerobically, and then that way all that is converted to a a NH4 form. I get so tongue-tied when it comes to saying ammonia, ammonium, and nitrate. Those are easy, but those two, ammonia, ammonium, is what gets me. So the NH4 is what we're after. Now we got to somehow stop these coffee grinds from decomposing. I found that if I just bring them home, get them in this form, it's about 4 or 5 inches, however deep, it starts heating up. And at that point, down in there, we're going to have fungal growth because this is definitely a high carbon source, which the fungal species really love. And it's moist enough that when I stick my hand in there, it gets hot. And this whole thing just becomes a solid mat. Like, you could pick it up and it does not fall apart. Within like 24 hours, this thing is meshed together like the fungi here, just zooming through it. Now, I still learning through the soil food web which fungal hyphae are the beneficial and the ones you don't want. I'm assuming with that fast of a growth going on that it's going to be either the oomycetes or the actinobacteria taken off, which is very possible. So when this starts getting hot, that's your bacteria telling you the reaction process is getting started, and they're multiplying extremely rapidly. So what happens just when bacteria is in the same place and they multiply that rapidly, it just sucks the oxygen right out of the environment. Therefore, underneath the surface area of these coffee grinds, it can't pull down enough oxygen to keep it aerobic. So I need to find a really good way to make this dry down fast and remain aerobic, because otherwise I'm losing that nitrogen to the nitrate form, which I don't want, because that's what the weeds are going to thrive on once I take this, put it out onto my agricultural fields. So this does take a little brain power, probably a little, labor too. It's a little labor intensive. So this is last week's bin, and you can see the color difference. I also think, this starts to get like maybe a white color to it. I looked at it under the microscope, do see some fungal hyphae and lots of bacterial activity. I did not see any anaerobic microbes, bacteria at all. So I was happy with that. But I'm not 100% sure what all anaerobic bacteria look like. The fungal, I'm not 100% whether they were oomycetes or which type of fungus there was. I need to get some photos up, see if anybody knows. And they're growing fast, so what I'm going to do this morning is I cut this bin in half. So I have another bin. I have 3 of these big, huge, 3 or 4, I don't know. I might get more. Big, huge bins. So I cut this in half. You can maybe see where the level was that I had it all week last week, turning it. And I just noticed, even turning it, it's still heating up way faster than what I can get that composting process stopped. So now I left it half is full, put the other half, and I've been turning it right during the critical period when it wants to start. This one hasn't even wanted to start heating up yet. And I know it takes about 2 or 3 days, and then I can start to feel that activity going after it's been basically, I guess, sterilized from running through that coffee machine. Then half, cutting it in half seemed to do the trick. We're not hot this morning. So it's last night. I went and got more of these bins yesterday. Cut this amount in half. That seems to be doing the trick. I don't have the moisture collecting, because see, the moisture is being produced through catabolism. So that's the microbes and the fungi breaking down the organic matter. That's catabolism. That releases the moisture. So more moisture just makes the whole thing go faster. It'll create more of an anaerobic condition, which then is going to feed more bacteria, which is then going to suck the oxygen out of the air. So that's why we need to be turning them, and being very diligent to pay attention to when those critical periods are of when it will heat up. And so once I get this super dry, because it does have moisture, you can see it's darker brown, got to get it super dry, then I can store it. I'll put it in 5-gallon buckets, whatever I can to keep the moisture away from it, so that I can slowly feed it out. It's also, I guess, a byproduct that you could sell to other small wormeries, and I don't even want to call them, I guess, small wormeries. I mean, in-home home bins, so that when they run out of their feedstocks, if they're feeding their kitchen scraps or something, then they can buy some of the coffee grinds. Now, coffee grinds also for our purpose of the eco-ag, making these amendments. So what we'll do is we'll feed the worms a certain product, and if you feed them a product that is a very high carbon source, then you're going to wind up with a high carbon vermicast. The high carbon vermicast is what your fungal dominance comes from. So we're going to want to choose products. Say we're going to be growing corn next year and we want a fungal dominant soil, so we're going to have to choose products to put into our vermicast or composters, so that we can get them worms to create a fungal dominant casting. And that's what my goal is here. So I'm going to start collecting these, drying them down, keeping that nitrogen source in the basically the nitrogen, I guess, form, so that when we convert it to ammonium, then the plants can utilize that. I'm just going to say NH4, so my voice, sometimes you might hear it wrong. I seem to mumble. I've heard that a lot. Anyway, so we want to keep that nitrogen in the NH4 form, and that is to convert it with aerobic microbes, and then also create a fungal dominant vermicast, which is to feed them food high in carbon. That's my goal here with this. Now, the third thing that I always do in my head is basically called carbon counting, is what I'm calling it, where I'm going through my procedures and say, hey, am I using power? Am I using carbon in order to do what I'm doing? So I could, put a fan on this or something like that, but I'm using electricity. I'm using a resource of some sort. Even if I'm, solar, still, what did it take to build the solar panel? It's probably still using carbon. So right now I'm just using my hand. I'm using carbon too, because I eat, but it's just something, you can do. You're hashing this out. I don't want to just go out and buy a fan and put it all on fans, because then we are using the electrical grid or whatnot to dry these out. So right now I'm just using, I will say I've added into this carbon factor, we do heat with wood, so the wood burner really dries out the air, and so I'm going to utilize that. So yeah, we're burning some carbon off by using that wood burner, but it's not like I'm just using that for drying down these coffee grinds, because you could do that. You could get a sort of a system that would dry stuff down real quick, run it through there, and lock this nitrogen into a good form where it can be stored for ag amendments. So one, we're heating our house with that, so we're not using propane, we're not using electric, and also, since we are running a carbon farm, I feel like we are kind of neutralizing that by what we're doing. So, you know, no, there are no laws out there on carbon counting and points and how much and which one are you, negative or positive. Oh, they're starting to become, I guess, laws out there. I shouldn't say that, but this is just something in my own head that I do to try to narrow down my footprint. Because I could go out and buy a whole bunch of stuff to do this, but it's just like shredding your cardboard. You know, what's the easiest way to do it without buying a cardboard shredder or a lawnmower or whatever you're going to be using in order to accomplish that goal to be able to be more carbon friendly? Kind of something like that. Anyway, this is what I do every morning just to make sure these coffee grinds are not getting... I just want you to key into that fact that, you know, you could be losing the nitrogen out of this, and then not only losing it, but you're converting it into a detrimental form of nitrogen, which is the nitrates that, you know, leach from the soil and or create the nitrogen drag on your crops. I'm not saying all of you people are using your vermicast for eco ag, but just to be aware that, you know, it is happening, and maybe some ways that you can start changing that and storing your feed stocks for your worms with that in mind. Because if you are going to sell your vermicompost, I know this is getting really big right now, you know, with the Johnson Sioux methods of farming, and understand that even though you're organic or whatever, if your feedstocks or your amendments haven't been stored properly, haven't been fed the right feedstock to make, you know, either a bacterial dominant or a fungal dominant amendment, you're going to sabotage your whole work that you're trying to accomplish, because you've just maybe added a ton of nitrates to your field. Now your weed population is going to be so crazy that it's going to make you quit. And so I'm going to try next spring to actually do this, being mindful of these practices and procedures here now, to see what kind of a difference I get. I'm not gonna go out and say this is the end all be all, because I haven't done it myself. That's one thing I like, peer review, and that's what I'm going to be doing with this program. Is I'm going to say, let's put our money where our mouth is and do it. And if it works, then I'll start pushing a lot harder and doing a lot more of this in videos, so that you can see about where my head's at and why I'm doing what I'm doing, and taking the measures that I am in order to keep these feedstocks healthy. There's so much more to it than I ever imagined, but I just, after finding out about what all is in the soil, I just, you know, why was I so stupid? And I'm going to try to correct that stupidity. Now, it is not easy as far as labor goes. It's pretty labor intensive, but if you get the knowledge behind it, it is pretty easy once you understand it, and you just got to do some simple things, I think, and hopefully it'll be a beautiful thing. Okay, so it won't take up any more time. Maybe you all like to listen to me ramble, maybe not. You can always cut the video, but be sure that if you want to see more in the future, you're gonna have to click the button. So I think I went over everything. In this video, that there probably won't be, unless I have a catastrophe or feel like I need to give you some more information, I will. Otherwise, it's all good. Keep saving and collecting your waste products, which are going to be extremely valuable in the future.